Have you ever eaten a bowl of cereal with milk and noticed how the flakes float while the milk stays at the bottom? Or maybe mixed rice and beans for lunch and thought, these are together, but still kind of separate. Congratulations, you've just made a mixture. Today on School Subjects Online, we'll explore mixtures, the difference between homogeneous and heterogeneous mixtures, and the cool methods of separating mixtures like filtration, evaporation, sieving, decantation, and even magnetism. So grab your curiosity, let's mix things up. What is a mixture? A mixture is made when two or more substances are combined physically, not chemically. That means each part of the mixture keeps its own properties. Think of it like a group project. Everyone's together but still doing their own thing. Here are some common mixtures. Air, a mix of gases. Salad, a mix of veggies. Sand and watermilk and chocolate syrup. Quick fact, unlike a solution, not everything in a mixture dissolves completely. Homogeneous versus heterogeneous mixtures. Now let's compare the two main types of mixtures. 1. Homogeneous mixtures, the even mix. In a homogeneous mixture, everything looks the same throughout. You can't see the separate parts because they're evenly mixed. Examples: salt water, vinegar. Soft drinks. They look uniform. The salt, sugar, or gas is completely spread out in the liquid. 2. Heterogeneous mixtures, the uneven mix. Here, the parts are not evenly mixed, and you can see the different components. Examples: fruit salad, cereal with milk, sand and pebbles on the beach. Try it yourself. Mix oil and water. They'll separate into layers because they don't mix evenly. Quick question: is orange juice with pulp homogeneous or heterogeneous? Answer: heterogeneous, because you can still see the pulp. Methods of separating mixtures. Mixtures can be combined easily, and they can be separated just as easily. Scientists, and you, can use different methods to separate mixtures depending on their properties. Let's check them out. 1. Filtration, used to separate a solid from a liquid. Example: filtering coffee grounds from water or sand from muddy water. The filter lets the liquid pass through but keeps the solid behind. 2. Evaporation, used when a solid is dissolved in a liquid. Example: getting salt back from salt water. When you heat the mixture, the water evaporates and leaves the salt behind. 3. Sieving, used to separate larger particles from smaller ones. Example: removing big stones from rice or flour. That's why bakers sieve flour to make it smooth and soft. 4. Decantation, used to separate liquids and solids that settle at the bottom, or two liquids that don't mix. Example: pouring out water from rice before cooking, or separating oil and water. 5. Magnetism, used when one of the materials is magnetic. Example: removing iron nails from sand using a magnet.
Pretty cool, right? That's science at work. Wow!
Fun fact, in recycling centers, giant magnets are used to separate metal cans from other trash before they're reused. Real-life applications mixtures are everywhere, and understanding them makes daily life easier. Cooks mix ingredients to make sauces, soups, and juices. Scientists separate mixtures to purify chemicals. Engineers use separation processes in water treatment and mining. Even farmers separate grains using sieves. So the next time you're in the kitchen, classroom, or even the beach, look around. You're surrounded by mixtures. Let's summarize what we learned today. A mixture is a combination of substances that can be separated physically. Homogeneous mixtures look uniform, like salt water or vinegar. Heterogeneous mixtures show visible parts, like fruit salad or sand and stones. We can separate mixtures using filtration, evaporation, sieving, decantation, and magnetism. Now think about this. If mixtures can be combined and separated so easily, how many different mixtures do you think you encounter every single day? Hint: more than you can count. And hey, if you enjoyed this lesson, don't forget to like, share, and subscribe to School Subjects Online for more fun and engaging science videos. Until next time, stay curious, keep experimenting, and keep learning.